Still for Hess's law. Definition: Hess's law, also called the law of constant heat summation, states, open quote, the total enthalpy change in a chemical reaction is the same regardless of the number of steps or the path taken, provided the initial and final conditions are the same. Close quote. Mathematical form: delta H text total equals delta H1 plus delta H2, delta H3 plus dots, where minus delta H equals enthalpy change. The reaction may occur in one step or multiple steps, but total delta H remains constant. Key concepts: 1. State function. Enthalpy H is a state function. It depends only on the initial and final states. 2. Additivity. You can add, subtract chemical equations and their enthalpy changes. 3. Reversing reactions. When a reaction is reversed, the sign of delta H is also reversed. 4. Multiplying reactions. When a reaction is multiplied by a coefficient, delta H is also multiplied. Applications of Hess's law: to calculate delta H for reactions that are difficult to measure directly, to determine enthalpies of formation, combustion, or bond energies, in thermochemical cycles, Born-Haber cycle. Example: suppose text CS plus O is square 2 quad delta H equals minus 393.5. Text CS plus 0.502 delta H equals minus 110.5. You can find text CO plus 0.502 using delta H equals 393.5 minus 283.0. Now there are 25 MCQs on Hess's law. 1. Hess's law is based on the fact that enthalpy is a path function. B. Energy is conserved. C. Enthalpy depends on steps. D. Heat cannot be measured. Answer 2. Hess's law is applicable to A. Reversible reactions. B. Irreversible reactions only, all types of chemical reactions. D. Physical processes only. Answer 3. Who proposed Hess's law? A. Boyle. B. Hess. Charles. D. Gibbs. Answer B. The principle behind Hess's law is that enthalpy is A. Quantity with direction. B. State function. C. Path function. D. Constant for all reactions. 5. When a chemical equation is reversed, what happens to delta H? A. Doubled. B. Remains same. C. Becomes 0. D. Sign is reversed. Answer D. 6. When a chemical equation is multiplied by 2, delta H is A. Divided by 2, multiplied by 2, C. Remains unchanged, D. Made negative. Answer 7. Which of the following is true about Hess's law? A. It depends on reaction mechanism. B. It's independent of path taken. It's useful only in labs. D. It only applies to gas reactions. B8. Hess's law is used to calculate A. Volume, B. Mass, C. Enthalpy change, D. Temperature. Answers 9. In Hess's law, the total enthalpy changes: A. The average of steps, B. The product of steps, C. The sum of step enthalpies, D. 0. Answer. 10. Hess's law works because enthalpy is independent of A. Physical state, B. Pressure, C. Reaction pathway, D. Energy released. 11. The unit of delta H is usually expressed in A. Joules only, B. Kelvin, C. Kjoules per mole, D. G per mole. Answer C. At 12. If they chum I made 50 kilojoules per 30 kilojoules, total delta H equal A plus 80 kilojoules, made is 20 kilojoules, D plus 20 kilojoules. Answers 13. What type of function is enthalpy? A. Derived, B. Independent, C. State, D. Paths, or C. 14. Hess's law is most useful when A. H is easy to measure directly, B. H is difficult to measure directly, C. No data is available, D. Equilibrium is reached. Answer B. 15. If a reaction is exothermic, delta H is positive B, negative C, 0, D. Undefined. 16. In Hess's law, you can add reactions if A. They have common products, B. They involve same gases, C. Intermediates cancel out, they have equal delta H. Answer 17. Hess's law is mainly related to aedics, equilibrium, C. Thermodynamics, D. Electricity. 18. Which of the following is a direct application of Hess's law? Avogadro's law, B. Bond energy calculation, C. Freezing point calculation, D. Kinetic energy. Answer B. 19. Enthalpy is measured at constant: A. Volume, B. Temperature, C. Pressure, D. Entropy. Answer C. 20. Delta H for a formation reaction is the enthalpy change for A. Breaking all bonds, B. Forming 1 mole of compound, C. Evaporation, D. Neutralization. Answer B. 21, if H2 plus HAPO2H2O, delta H equals minus 286 kilojoules. This is an endothermic reaction, B equilibrium reaction, C exothermic reaction, D redox reaction. Answer C, 22. In a thermochemical equation, delta H is A, always 0, B, only used in ideal gases, C, written alongside the equation, D, ignored in calculation. Answer C, 23. What happens to delta H when temperature changes? A, always increases, B, may slightly change, C, drastically increases, becomes 0. Answer B, 24. What is conserved in Hess's law? A, volume, B, enthalpy, mass, D, pressure. Answer 25. In Hess's law, which value must be known? Activation energy, B, entropy, C, delta H of known steps, D, reaction rate. Answer